If you can please come, the floor is yours now.
I stay here.
To have a tea? Yes, you can go directly and have a seat.
Thanks. Thank you.
Okay, and now we have the last session of the event. We are happy to have this discussion panel with our honorable members of ValgrAI Scientific Council. We have Ramón López de Mantaras from the Consejo Superior de Investigaciones Científicas, Carme Torras, also from the Consejo Superior de Investigaciones Científicas, the SIC. We have Tom Dietrich from University of Oregon, and George Gottlob from University of Calabria. So, well, let me thank you very much for your support, for your advice, for ValgrAI Foundation. We are really grateful for the advice that you give us and you have been giving us during these years, and I can only say thank you very much. And now the floor is yours.
Thank you. All right, so I'm in charge of moderating this discussion. I passed a few questions to the members of this panel. As well, you're Gottlob. There's no need to introduce you. You just introduced 1 hour ago or so. Then we have Tom Dietrich, I think it's well known also to most of you, from Oregon State University. So one of the pioneers of machine learning, one of the old guys of AI. We were discussing some time ago, just at lunchtime, that we are now somehow the old guys of AI. Oh my goodness. Carme Torras, which is, you know her for sure too. Yes, it was last year that you gave this invited talk, yes. That was on social robotics for assisting people. And myself, I'm in charge of the Scientific Council, chairing the Scientific Council. So I propose the subject of the discussion to discuss today about you know, AI in science. Huh? What role is AI, and particularly generative AI, but not only. There is a life outside generative AI still. It's playing a role which is more and more important. That's very clear. I read that in the last 10 years or so, well, from 12 to 22, the use of AI in science has increased by quadrupling. So it's like 4 times more. And that was until 22. But then I found another piece of information recently that from 22 to now, which is only 3 years, it has already doubled. So in the last, let's say, 14 years or so, 13 years, it's tenfold, so 10 times more, one order of magnitude, which is quite impressive, right? So one of the questions that I wanted to put on on the table, on the panel, is will AI accelerate discovery in a time where scientific progress appears to be slowing? There were some writings, some papers that were giving some hints, some indications that maybe the scientific progress was somehow, if not slowing, so reaching like an asymptote. No? Like many groundbreaking results didn't seem to follow a sharp increase somehow, no? And some people believe that there is this saying that AI may change the situation, so may accelerate the scientific progress. So that would be one question that then we have a few others, right? But this would be my first question to you. I have my personal view too, but anyone who wants to start, I mean, I will not pose question to a particular person, but just anyone that feels that has something to say or wants to say something about this can go ahead. So will AI accelerate discovery? Do you think this will happen or is happening?
Is it open? Yes. Yeah. Well, in preparing for this panel, I looked into what was written about this. And there is a survey on Nature, published in Nature last year, in 2023. They asked 1,600 researchers how do they think AI could benefit research. And most of them say that that AI will accelerate a lot. For instance, programming. Nowadays, many people use ChatGPT or others to program. So, yeah, to write code, also to gather data, well, I have here the survey, also the computation time, the several hypotheses that could be tested at the same time, and so on. But they see also some problems, and some were exemplified by Georg before, which are frauds, fake research. What else they said? The increased reliance on pattern recognition without understanding anything. So the fear I have is that researchers do the same. I mean, rely a lot on correlations and things like that, and not really understand what else. Yeah.
I think this is a crucial point, because one thing is to increase the quantity, the volume, the amount of findings, but does this automatically mean that there is more understanding, more knowledge? Because it's not the same. There are examples of this that have been published also on this drawback. One thing is, okay, you have in terms of quantity, but in terms of quality of truly discovery, because there are after all we are in phase of techniques that have this black box type of nature, right? Which is a limitation, and this doesn't go along very well with the fact that with discovering really new knowledge.
So one of my dreams, I guess, and I still have it as my pinned tweet on the site formerly known as Twitter, is that we could build a knowledge base of scientific knowledge, of the knowledge we believe, and that would have the provenance back to the sources, ideally to the experimental data. or to the mathematical proofs. Because right now, science is largely a faith-based exercise. We trust the papers we read and so on, but errors easily creep in and can propagate for a long time, and it can often take the field a long time to recover. We see this particularly in medicine, but I think it's true in other areas, even mathematics. So I guess that's one place where perhaps with the support of LLMs and maybe also theorem provers and automated statistics, we might be able to do careful provenance of the things we believe are true in the literature. I mean, we're already seeing a big impact in some of these things like the deep research tools. I think Google, OpenAI. There's a company called Elicit, right, that claims to be able to write a review article for you, for a specific customized query. So I think that might be a way that we could avoid repeating work that's already been done, or maybe be smarter about replicating work that's already been done to check it. There are other places, though, where I think there are huge opportunities that we're seeing. You may have heard of this new telescope, the Vera Rubin telescope, that was just returned its first images. Each of those images is a 6 gigabyte image, and they expect to collect 10 to the power 16 bytes over the history or the operating period. So just cataloging and querying, clustering, and anomaly detection over all of the astronomical objects that those images will collect is very likely to uncover novelty. And that's at a scale that people could never do. People have been working on AI for astronomy now for, I don't know, maybe 20 years or so, back to just finding all the volcanoes on Venus. I remember a paper many years ago. And there have been already discoveries coming out of that. So I think, but then there also, there's a website called openproblems.bio, which is based on this single cell analysis with microfluidic instruments, where again, they're collecting massive amounts of data at individual cell levels for either basic biology or cancer biology. And there are opportunities, well, it will be absolutely required to use AI-type tools to analyze and understand that data and build causal models. And of course, there's AlphaFold and its successors, material science. And I saw a really interesting talk last year at a meeting in Germany from Veronica Eyring, who's, I believe, from Sweden. She's one of the gods of atmospheric science. And she was applying symbolic regression methods to atmospheric science data and getting very interesting expressions. They're using basically a fairly simple genetic algorithm type searches over symbolic expressions, and we're discovering not only equations that they knew, but some additional terms that they were able then to interpret as having a physical basis. And so I think that's also very exciting. Of course, all of the things I just mentioned don't have anything to do with large language models. They're all based on other AI technology. But I think there are immense opportunities there.
Yeah, I fully agree with what you said, but yeah, I can only add to that. I think AI is good for the scientists. Yeah. So we have a lot of tools now that we didn't have, right? Deep research, and even Google Scholar is based on AI in a certain sense. Yeah. Now, again, here we have to be a little bit careful, because what is the order of the result that we get presented? Yeah. The most cited paper is maybe not the one that is most appropriate for what we are looking. Yeah. But so one has to take all these predictions, this predictive AI, a little bit with a grain of salt, and has to maybe, in my opinion, not only look at the first results, yeah, tweak it again, the search, etc. Then there's this other type of AI, like protein folding, where you solve hard problems, MP hard problems, but once you have the solution, you know that this is a solution, because you see, this is now what you have, a protein with certain properties, okay? You have generated something that has certain properties that you can easily check it's just like an MP hard problem. This is an MP hard problem to get to it, but once you have it, you can say, now AI has discovered such a protein. Yeah, that's wonderful, because we will have new medicine, new pharmaceutical products, etc., but also new insight. Yeah, in what makes this, why, yeah, maybe you didn't even know why this thing would be so good and have this property. But now it has these properties, you have a thing, and you can prove it has these properties. So there's provable useful AI, and there's predictive AI, which is also good. We can predict something about the environment, for instance. Yeah? The environment, global warming things, and yeah, they are not 100% because they don't take everything into account, and still it's a warning sign for us, but we have to be also warned not to trust blindly everything. And then there are these results, interestingly, where you can 100% know. Now, here we have 100% a new molecule, and this new molecule has some very good properties. And before that, a scientist would have won the Nobel Prize for this. Yeah? And now almost the system, still the scientist behind it, but the system wins the Nobel Prize. So I think, yes, AI dramatically accelerates research in various ways, predictively, but also, how to say, solving constraints and generating new matter, new molecules.
Yeah, let's go for other questions, other issues. AI being now such a huge hype, it seems that everyone has to use AI very often without deeply thinking or making a serious reflection of whether it is really necessary, or maybe there are other techniques that might work as well. We know that this happens, that are maybe more statistical, more classical statistical techniques, for instance, right? That may use, but sometimes they work as well or better than a sophisticated AI model, right? And this, because of this hype, and that everyone wants to do something to apply AI. In science, this happens too, especially this widespread use of machine learning by researchers who lack expertise. Researchers in other fields, in sciences, biologists, physicists, economy, that actually they lack expertise, and sometimes they get results that they have not enough knowledge of the limitations of the models, of the limitations of the tools they are using, and they reach conclusions, and they come up with conclusions that maybe are not correct, and often they are not. This is a very well-known example of this use on the predicting COVID infection, that you probably all of you know, that it turned out that in the training's data, large majority of the COVID positive were adults, all people, and on the contrary, those that were not positive on the COVID were children. Actually, this model what was really differentiating or discriminating was age, not COVID. So this is a very good example of using these models, these machine learning models, off the shelf, basically almost, and running the system, and whoops, wow, I got this result, and I feel very happy because I found a good predictor of COVID, right? And it was not at all the case, as you know. No? And there are many other examples. The one with this, I don't know how many hundreds of thousands of new crystals, of new materials that were even published. I think it's Nature of Science, extremely top journal, that it was rebunked. It was rebunked because then people, experts on the field, and they published that on one of these very famous material science journals, said that none of these supposedly new findings were actually new. And those that appeared to be new, they were not stable at all. So this was completely useless. No? So this is like examples of, of these shortcomings, these problems of using this machine learning, in particular machine learning, well, in that case, where when there is no much expertise. I mean, AI, obviously, machine learning is not magic. If you are, it will not make you much better scientist by using it. That's one thing. I mean, I don't know if you want to comment about this issue.
Just ad hoc. I mean, there's a book, a very famous book. I forgot the author name. How to Lie with Statistics. Yeah. And now there should be one. How to Lie with AI. Probably it already exists. But
yeah, want to say something along that?
I mean, I'm not optimistic because look at all the abuse of p-values. Scientists are taught to use p-values as a measure of the strength of an effect, but it isn't really that. It's mostly a measure of sample size, right? It's worse with machine learning, I think, because machine learning algorithms, I call them information-seeking weapons. They're just looking for a correlation, and they'll find it, as you say, in the adult versus child, or finding a caption up in the upper left-hand corner of the picture that turns out to be barcoding the answer in some way. I mean, I've even made that mistake myself in a computer vision project where it turned out, instead of looking at the object, it was reading little bubbles that were forming on the edge of the microscope slide, and that was encoding the class label. It's you could call it how to fool yourself with machine learning as opposed to how to lie, because people don't deliberately do this. So how can we teach proper methodology? I think the holdout method is powerful, but people replace that with cross-validation instead, and cross-validation, it's very easy to then tune against the cross-validation result and completely invalidate your analysis. So journals need to, I guess, have methodological checklists. We need to train people to use the holdout method honestly, but it's very difficult. And since I've fooled myself, I don't know.
Yeah, I think training programs for scientists is very important. And well, actually in Spain there are several initiatives. iHub, for instance, is one. That they do courses specifically for scientists on how to apply AI in their fields. And there are many projects, small projects going on this area. And also ValgrAI could make a difference in this respect, not just educating citizens, which is very nice, but also scientists on how to use, because there are many scientists interested in using AI in a proper way, but it's just that they don't know how to do it. And another thing I wanted to raise is that, well, another possible problem of AI is that scientists rely so much on AI that they do not train themselves in the subject matter and delegate the decisions and so on. And the risk is that we scientists end up being peripherals of the machine, that the machine does the good work, I mean the creative, the design of experiments, etc., what we like to do, and we are just
Delegating too much?
And we are the peripherals in the sense that, for instance, experiments with animals, of course, the machines, the AI cannot deal with, feeding the animals and so on, but they can design the experiments to be done. Mm-hmm. So maybe scientists in experimental animal design could end up being just the peripherals of the machines. So we have to be careful of what we delegate. If we delegate the important, the creative things, we can end up being machines ourselves.
It may affect negatively the critical thinking, which is absolutely crucial in science. I mean, scientists, first of all, one of the things is very important we have to do is to be a little bit skeptical. And they said, no, let's be careful, you know, slowly, thinking slowly, and waiting, reproduce results. So the issue of reproducibility is a big issue, a big problem actually we have in AI. There was I remember now, came to my mind right now, some time ago, I don't know if it already still exists, there was a journal called the Journal of Irreproducible Results. Believe it or not, this journal existed. It's not a joke. It's not a joke. Well, maybe the journal was, those that set up this journal, I think this journal was founded to raise awareness, obviously. Yeah, I know, Tom. Raise awareness of the issue of reproducibility, but the journal existed. It was not something invented. And I remember at some point, I don't remember when was that, long time ago in one of these AI conference, that this came up and someone said in a panel similar to this one, said, you know, AI, we could define AI as the science of irreproducible results. So I was, he said, she added, I don't remember who was it. Well, let's hope that when the field matures, you know, as time goes, the AI will be more mature field, and maybe we become a real science, like it's more classical or standard sciences, and it will be a science of reproducible results. Do you think that AI is also puts into risk the problem of reproducibility?
Well, certainly. I'm very concerned. There is a lot of enthusiasm to automate AI research. And you see, particularly automating machine learning research. And I attended a talk a couple of weeks ago by Zoom, where the authors were basically defining a successful research outcome as one that would get accepted by conference reviewers. And they used an LLM to simulate the conference reviewers. Catastrophe, right, from my perspective. You know, you're just doing the Turing test now. You just got to fool the reviewers. That's not science, right? As you say, a scientist has this strange role of having to be optimistic that the thing they're studying can be understood, and pessimistic that their current understanding is wrong. And walking that, we kind of have this split personality. One place that gives me some hope, though, is we also now have Judea Pearl and others, this theory of causal inference and causal reasoning. And I think we should be teaching scientists these tools. And not only teaching them, but creating better, very easy to use tools. If you want people to do the right thing, let's give them tools that make it easy to do the right thing. And because I think that a lot of the failures we've been mentioning are just failures of causality, finding some spurious correlation instead of the underlying causal phenomena. So maybe there's hope there. But unfortunately, in machine learning, especially with all this, you know, we heard this morning about alternatives to just chasing the leaderboard. But this leaderboard chasing just encourages people to try kind of random changes in neural networks and see if it improves their score. This gives absolutely no understanding of what's going on, but that's kind of the mindset right now, especially among younger researchers. So we're in trouble.
I can only agree with what was said.
Of course, we're also getting lots of fake papers, just generated, LLM-generated papers submitted to, say, to the archive, for instance, which I'm involved with, and it's a huge problem for us there. We used to reject only about 1% of submissions to archive, but I think in computer science we're up to 7% now, and that's partly a sign of a lot more junk. Well, what's the technical term? Slop, I believe, being submitted.
But I think that there's also another point which is related to this. When is AI applied to humans? When you apply AI to humans, you have to be very careful. No? Credit rating, which is extremely often wrong. I wanted to buy I wanted to get a credit card and I got it with a limit of 500 because in the house where I used to live, I lived in a house where before somebody was living who didn't pay their bills, and so I got paid. Actually, that's a ghost that hunted this house, basically. The new version, the electronic version of a ghost. Yeah? Okay. Yeah. So I got a bad credit rating because somebody was living, and the system obviously had generated a kind of rule or associated this with me by saying, if you live in the same house as somebody who doesn't pay their bills, then also you will not pay your bills. Yeah? But I wasn't living with this guy because this guy was living there before. But there was no database at all. Yeah? But in England, there is no database about people. Yeah? There's no people don't have to register in any database. Yeah? So the system just thought that this guy was living there, and unethically, it generates the correct rule. The rule is correct statistically. If you live together with somebody who doesn't pay their bills, statistically you don't pay your bills. Yeah? But you cannot apply that to humans. Yeah? It's very risky. And so I think for this we really need to have also research. Yeah? I mean, also in research such things occur. Yeah? And we need a catalog of questions that we have to ask ourselves before we take an AI tool and apply it for decisions that have consequences for people. Yeah? And I think there's not enough research on that currently. And it's very, very critical.
Well, yeah, let's go forward. There's another issue that I had in the list is the problem of data leakage, right? Where information from the test data influences the training data. So this contamination, data leakage, data contamination. Of course, this in science, when you use AI for doing scientific research as a tool for helping your research scientists, your research work, that's an extremely serious problem because you may think that the AI did something absolutely impressive, incredible, and it turns out that it was already there, right? More or less, the patterns were already in the training data. And this has been also identified as has been pinpointed as a huge problem on the use of AI in science. What is your thinking about that?
You know, this problem, the abstraction of independent and identically distributed data is rarely encountered in the real world, right? There often are correlations among the data points, and when we treat them as independent, we make errors. This is extremely obvious in spatial data. So if you have you have data points measured with XY coordinates, and if you just randomly split into training and test data, probably every test data point will have a training data point that was very close to it spatially. And of course, if there's any kind of autocorrelation in space or in time or in a social network or any place where you don't have independent data, you'll have trouble. I have a colleague who is one of Udea Pearl's students who has been working on, again, causal reasoning tools to be able to tell you when it is safe to go ahead and treat the data as IID versus when you need to apply some corrections. And usually what you find out is although you have 100 data points, say, you really only have 20 data points in terms of real degrees of freedom because of the correlations. And it also influences if you want to do some sort of holdout test, how do you do that split into training and test data? How do you try to get an independent test if in some sense you have only one instance, which is a graph or a map? These are hard. There are still research questions there to be solved. I mean, it's just like also a database. Right? Each tuple is not independent. but naively, we often treat it as if it is, or we calculate the universal relation and then treat each.
Yeah, I want to add something about copyright because it's also related to it.
Yeah.
People now say, well, all these LLMs actually are trained, and they, in some sense, they violate copyright in a small, not in an exact sense, but of course they take pieces of text, etc. Here, I have a contrarian opinion. Actually, I mean, on one hand, I'm angry that the search engines then claim copyright for what they produce, but they steal it from the entire web. Yeah. On the other hand, I have to say, I believe that they are doing that search engines and LLMs in particular that can be used as search engines are very good for humanity. Yeah, they help. Yeah, and so if something is good for humanity, you have to sacrifice something that blocks it. Okay. So, for instance, if you want to build a new railway in a country, then you expropriate territories on the way. You have to expropriate and you have to give money to the people. Yeah? You have to compensate people. And I think that will be a model in the future. There has to be also a new model for compensating people. In part it already exists because sometimes I get money just because I publish things. So there is some organization, I forgot the name, that collects money, I don't know from whom, and gives you money. But in general, I think there should also be a kind of expropriation of this copyright. It doesn't have to go too far, so to allow search engines or LLMs in particular to take this knowledge and to mix it with other stuff and do something. So then there need to be a new legal model for this, in my opinion. Yeah? And expropriation is not always bad. Sometimes it's good if it serves a better goal, let's say, a better purpose.
Well, I will deviate a bit from this topic. So,
No problem.
yeah, is it? No, because we are talking about AI as a tool. Yeah? Yeah, that you can use it wrongly or you can, but it's always thought as a tool, which in my opinion is good. But there are all these projects now about building an AI scientist. For instance, Dr. Kitano last year talked about this Turing challenge, or how was it called? Nobel Turing challenge. So by 2050, they expect, I don't know if this is just a challenge in order to develop research or they are serious, but I know of other such projects in Europe as well. So this to me brings more difficult problems, say, or because if we leave to science to machines directly, then what are the authorized voices to say that this is good research for humanity or this is good research in itself? All this quality we are looking for, is copyright and everything, do machines will do it also? So I think it's a serious threat in the sense that we are somehow delegating essential values of humanity. And well, and they are working on this, so I don't know, I wanted to know your opinion on this.
Well, before we were mentioning the word being skeptical, I am very skeptical of Julius about this, and absolutely skeptical. There are people who talk about, for example, formulating an hypothesis, coming up with an hypothesis, or the aha moment. This is out of reach of AI, in my opinion. In my opinion, I mean, and I think it will be out of reach of AI for many, many years. I don't know if at some point this kind of capability will be possible. I know that there is some work on that. There is some work on there was this, I remember now the authors from UK, some time ago already, that set up a system that had also some hardware. It was not only on software, on turning off and on some genes, I think, and coming up with they said, well, I read the paper and I have to say that it was very cryptic. It was not easy to understand at all. It was obviously not reproducible again, in my opinion, hardly reproducible. And they pretend to say that this system was capable of hypothesizing, making an hypothesis, and then setting up, planning experiments in order to refute or confirm the hypothesis. You may know, have you heard about this?
Was this Ross King's work? Ross King?
Ross King was one of
he
the...
said this, AI, this automated
Yeah.
biologist
So
working for 15 years.
But that was long ago, and nothing else has happened.
Right.
So
I mean, now
are we in
you
the
can
same situation that we're again claiming that the AI will be able to do all the spectrum of what it means, of what it's to do science or to do scientific research? I have serious doubts.
Well, I think what we're going to see first is the automation of routine science. So we're seeing this in material science. I mean, despite that notorious paper, there are a lot of labs doing automated materials discovery, right, where they just, I'm familiar with some work at Caltech, where they use these sort of splatter, sort of like inkjet printing, to create mixtures of different materials, and then they analyze them spectrographically and try to understand what they've made and what its properties are. And certainly there's similar things happening in drug design. I'm very optimistic about progress in drug design. But in all these cases, and also maybe in mathematical theorem proving, right? We are setting the problem, and we're automating the very routine science part of generating all of the different, generating and testing different possible solutions. To go beyond that, we need to build systems that know why they would believe something to be true or false. LLMs have no concept, really, of truth, right? Because they also don't have any concept of their data sources particularly, right? Essentially, they've been told during training, trust everything unless it's too noisy or too rare. But I think that brings me back to my first point, which is, could we build a knowledge base that had the provenance links all the way back to why we believe something is true? And you would need to have that in order to be able to say, okay, I'm going to hypothesize something that we do not know whether it's true, and then I have to design an experiment that would provide a basis for believing it. I also saw a paper just last week, I think, from someone saying that most of the time when we do an intervention, experimental intervention, particularly in human and social systems, but also in medicine and in biology, we are rarely actually intervening on the variable of interest. We are usually intervening on what's known as an instrumental variable, right, in the causal thing. And so we also have to assess the relationship of that instrumental variable to the true variable, which may not be observable and may only be a theoretical construct, might not have validity, as we were discussing this morning. So I think there are so many problems that need to be solved before we could do that. But I don't think it's out of reach ultimately. I mean, to me, the reason I got into AI to begin with was to try to understand how is it that scientists come to know things are true, right? I mean, I can't remember which philosopher of science said, you know, the central question in philosophy of science is how we move from our common sense notion of the world to believing that quantum mechanics is what's going on. A completely and totally implausible thing. So, and how do we do that in a series of rational steps?
I wonder if maybe we should give an opportunity to the audience to say something or comment something or ask something. Anna, yeah, we can do that? Or I don't know. It's,
maybe I have to ask you to borrow me a microphone, but there is any question.
in case anyone is, you are not obliged, but, but if,
Vicente?
You don't talk about common sense. You don't talk about common sense. What do you think if it's possible to incorporate the common sense in this AI in order to solve problems that we can infer from?
I'm not sure I hear the question properly.
Common sense.
So the question
Common
is,
sense.
we didn't talk about common sense.
Oh,
And I guess from the scientific point of view, it's not common sense, it's uncommon sense.
common sense of AI or common sense in using AI?
Yeah.
Common sense in using it.
Using
Yeah.
it.
Well, yeah.
I think George
Yeah,
had
no.
very good examples of the failure of these systems to use the knowledge they have.
Yeah, I have another microphone. No, but I think now the LLMs have access to so many texts, yeah, and common sense can also be discovered in this text. Yeah, it's a kind of approach to normal behavior, and common sense is in all these texts, and the system could identify this, and so I think that there's a bridge because it can take learn a lot from what humans have written and done, and crystallize out some whatever is common sense reasoning. I mean, I dealt a lot with common sense reasoning in a very restricted framework, like default logic, etc. Yeah. So what are you doing by default? If you left your bicycle outside, and then you go back and you don't find it, yeah. Before you go back, you don't do a statistical reason. You say my bicycle is there, and when you learn that it's not there, you have to change your theory. Yeah, but you don't say that for this reason. I don't know, the Eiffel Tower is no longer in Paris or so, yeah? So you leave the rest of the world intact, but you change it only a little bit, and that's called also common sense reasoning, yeah? And I think systems, it's very difficult. I mean, people have made so many theories about common sense. What is common sense logic? Logic, for instance, yeah? Can we tweak logic to get common sense? But I think LLMs can help, because they can say in such a situation, yeah, this and this happens, and they describe, and they can learn from so many situations, and at the end can help us maybe even to find a good solution to something, which is based on human reasoning actually, on human descriptions or whatever.
There is some nice work by Yi-Jin Choi, who she did this work when she was at University of Washington. Now she's moved to Stanford, where she extracts and builds a common sense knowledge base by asking a set of queries to the LLM. So I think that, but you can get common sense about things that people have written about. Yeah. But common sense about the physical world is often not described linguistically. And some of that maybe can be learned by looking at video. But some of it maybe is going to be required by robots interacting with the world and learning about it that way.
I had with me this paper that I'm sure you may know. The title is "Why an Over-Reliance on AI-Driven Modeling is Bad for Science" by Arvind Narayana and Sayash Kapoor. No, they wrote this nice book on the snake oil, the AI snake oil. And they say something very interesting that obviously is connected with what we are right now discussing. And I think it's connected with what we said, what you said, Vicente, from the point of view of having the common sense is on us, and having common sense not to over-rely precisely on AI. That's a common sense attitude. Don't over-rely on the use of AI in science. I will read you just a very short paragraph. They say, which is, to me, sounds pretty obvious, but is very well said. Says, science is not merely a collection of facts or findings. Actual scientific progress happens through theories, which explain a collection of findings and paradigms, which are conceptual tools for understanding and investigating a domain. As we move from findings to theories to paradigms, things get more abstract, broader, and less amenable to automation. I think this, in my opinion, I understand from this this observation that, you know, when you're moving from findings to theories to paradigms, you know. It's true that going to the level of, well, findings, so AI can be very, very helpful in the findings aspect, phase, the finding phase, let's call it, right? In theories, well, you know, that's already very, very, very tricky, you know, because we know that every model is wrong, but some models are useful. I don't remember who said that. There's some famous scientist that said that at some point, which is quite true. So theories is careful. But then moving to paradigms, I mean, I don't know, huh? But in my opinion, this is really out of the automation, out of the reach of automation even in AI. I don't know if you want to say something along these lines?
Well, we don't know how to do that kind of deep conceptual change right now. I don't think we have very good models of it, and it's relatively rare in the history of science. Therefore, we also don't have a lot of training examples.
But maybe in the future we can teach you, I can learn more abstraction and then reason at a very abstract level and recognize that something is a paradigm shift or something like that.
Yeah, but up to what point, if we delegate into machines the findings, the analysis of data, and for instance in mathematics, the proving of the theorems, which now they do quite well for the regular mathematics. But then if this is delegated to machines, genius, to make really a paradigm shift, or if there are no regular mathematicians, to me there will be no genius mathematicians, because they need this, I don't know how to say it, but in castellano, or in caldo de cultivo, no? If all this is in machines, maybe humanity will lose this capability. Then we cannot transfer to machines either. Well, I'm being a bit philosophical here, but I think it's a real threat. I don't know what you think, but how many average mathematicians to give birth to a genius?
It's a social aspect, science.
Yeah.
It's not something that an isolated AI, no matter how powerful it is, in my opinion, might model or somehow, I will not say substitute, I don't like this word, or compare to the whole social and collaborative aspects that are behind scientific progress.
Our colleagues at the Institute will build a multi-agent system that will mimic the scientific community. I mean, I think it's quite surprising that a panel with AI people on it, a field dedicated to attempting to replicate all of human cognitive activity, says some things are impossible. We don't know.
No, we don't
I think
know,
you know, I think right now, with the state of machine learning, we cannot learn good abstractions. So we can barely take baby steps in this direction right now, and I guess we need to proceed with great humility, both for what we might achieve and what we might not achieve.
Well, there are many other things that we could discuss, but I don't know, when should we finish, Anna?
It's already time.
More or less now?
Yeah, it's okay.
More or less now, yeah? Okay. Because, you know, there are these issues about, you know, cheating with AI allows you to cheat much more easy, and, you know, acting not on good faith and falsifying things, or there are many issues now, using AI even to write the papers and forgetting to delete the typical sentence, oh yes, here it is, here's the abstract of ChatGPT or things like this, no? Or using AI to review. So there are other challenges which are, in my opinion, are maybe less, in my humble opinion, are maybe less interesting than what we have been discussing. I think it was more deep, right? More deeper. But there are still other things right, around. around the use of AI in science that it would be interesting not to forget. And well, I don't know if call it a closing sentence, it sounds very pretentious, but something like in the sense that, okay, use these tools, but with a lot of common sense, right? Okay.
Yeah, because we're seeing the rise of deep fake research, deep fake science. Yeah. It's a mess. And because I look at all these submissions to archive, I don't look at all of them myself personally, but I look at many of them, and we see things like illustrations generated by one of those models, and you know, things are misspelled. It's obvious that it's a fake. So the person who produced it didn't even bother to check the output at all, as you say. But on the other hand, we are having to team up with Google, for example, to try to use some of their LLM detection, fingerprint detection, to detect papers that are synthetic. Yeah. So.
Georg, Tom, Karma, thanks very much for being here, even in this debate. Thank you all.
Thank you very much. And now with Vicent, General Director at ValgrAI, we have to thank our Scientific Council for this interesting panel, for your support, and everybody, all the attendees for being here and sharing also your knowledge and thoughts. And now, Vicent is saying something.
Thank you, George, Tom, Karma, Ramon, for this nice panel. We hope that all you have enjoyed this forum, and we look forward all of you, seeing all of you next year. Thank you very much to all the assistants, in here and online, also the online assistant. Thank you very much, and we seeing you next year here. Thank you.
Thank you.